Hello everyone, we are Group 17 and our video project is on ammonia for crop fertilization. Starting with the background, some physical and chemical properties. Anhydrous ammonia is a colorless, non-flammable liquefied gas, and it has a smell similar to our household ammonia, which is a pungent odor. Chemically, ammonia is 82% nitrogen and 18% hydrogen and has a chemical formula of NH3. It can be produced naturally or artificially, and the toxicity of it depends on the concentration being used. Ammonia is produced by combining nitrogen from the air with hydrogen from natural gases and other hydrocarbon sources, and then that can be compressed and transported as liquid under pressure. And at the bottom here is the tanks they use to store it. A little on the history. In successful farming cultures back in ancient times, they found that intensive farming reduced soil nutrients, which led to lower crop yields. So they learned that if the soil is amended with natural fertilizers, at that time they tried animal feces and discarded foods, and they found that it helped recharge the soil. They also tried crop rotation with legumes like peas and soybeans, and that also helped heal the land. And from all these methods, the key soil component being provided was nitrogen. With this information, in the 1900s, agricultural scientists found that nitrogen is the key player, and ammonia could be used to supply the needed nitrogen to the soil. And since the world population was growing and still growing really fast, food crops need to keep up with that pace. So in the mid to late 1800s, a large natural ammonia source was found on a group of islands off of the coast of Peru, known as the Guano Islands. And these islands were home to millions of seabirds. The area was really dry and didn't get much rain, so it helped build a lot of feces from the birds, and that became a source of ammonia for the world at that time. And they used it mostly for fertilizer, and then some also used it for gunpowder. And with a span of 30 years, 12 million tons was gone. And at this rate, obviously, the ammonia in the islands was not going to last for very long. Therefore, we need a solution to make ammonia fertilizer. And this led the pair scientists, Fritz Haber and Karl Boch, to come up with a way to produce ammonia in large quantities.
The Haber-Bosch process. The Haber-Bosch process was discovered by the German scientist Fritz Haber. In 1909, German engineer Karl Bosch was funded alongside Haber to develop a commercial-scale production of ammonia. The Haber-Bosch process was created as a solution to aid the food crisis in Great Britain of 1898. Haber discovered the reaction between nitrogen and hydrogen forms ammonia, which is now the main component of nitrogen-based fertilizers. The process requires nitrogen from air, hydrogen gas, and water. It also requires a pressure of 200 atmospheric units and an iron catalyst. Let's go ahead and take a look at a virtual diagram of the Haber process. Essentially, what happens in the Haber process is that the nitrogen gas and the hydrogen gas are fed into the reaction vessel. The mixture of gases goes up the compressor and into the converter. The converter is heated at 450 degrees Celsius, and it is made up of iron catalyst beds, which are the key for the reaction between hydrogen and nitrogen. The gases will reflux in the heated reaction vessel and begin to form ammonia. When ammonia is formed, it'll seep down into the cooling condenser, where the ammonia product will remain due to having a lower boiling point than hydrogen gas and nitrogen gas. Excess hydrogen and nitrogen will seep out through the left of the cooling condenser, go back up and into the converter, and it will continue to cycle until all ammonia is formed. So what are the benefits of having ammonia as a fertilizer for plants? Well, as a reference to the history slide of ammonia, we know that plants readily use nitrogen as a nutrient. Another benefit is that during the process of creating ammonia, you can also produce nitric acid, urea, and ammonium nitrate, all which can be used in medicines.
So I'll be going over the harmful effects that ammonia fertilizers can bring. Firstly, when excess ammonia does not get utilized by crops, these can get evaporated into the atmosphere, causing many sorts of problems, such as negatively impacting air quality, imposing large health risks to many, especially those with respiratory diseases. Also, the overuse of ammonia fertilizer can increase overall soil acidity, since the nitrification process of ammonia could potentially release excess hydrogen ions into the soil, eventually acidifying the soil over time. Additionally, excess nitrogen that aren't assimilated can run off into bodies of water, causing a nutrient-rich environment for algae to overgrow and cause unfavorable living conditions for marine life due to lack of oxygen and the contamination of water with cytotoxins. The process of making ammonia is energy intensive, making it very expensive. With this in mind, the process of creating ammonia also manufactures 1.87 tons of carbon dioxide into the atmosphere, contributing to global warming. This is an example of a body of water that's been eutrophied, and these are the effects of nitrogen deficiency in crops.
Ammonia fertilizers look like for our world. As we know, ammonia fertilizers does promote plant growth, and it can lead to strong, thick green stems and leaves of their plants, increasing crop yields. Increased crop yields allows us to have more food security around the world, which would benefit the United States, as we have more than 44 million Americans facing hunger today. However, the process of creating ammonia fertilizer is very intensive on the environment, and it significantly impacts climate change. Gases that are released from the process of making the fertilizer contributes to greenhouse gases, which traps heat into the environment, into the atmosphere, and that results in global warming. Long-term exposure to ammonia also has health risks for humans. High concentrations of ammonia can impact human health by causing conditions such as like chronic cough, asthma, and then also a condition called reactive airways dysfunction syndrome. So it's like asthma caused from being exposed to ammonia. With those things in mind, it's also good to look at alternative courses of action that we can take. So one way to go is with organic sources like compost and food waste and sewage that can be used to add nutrients back into the soil. Using organic fertilizers are better for the environment, and they help to reduce pollution. So the organic products can be used as fertilizer through the breakdown of their materials, and then the decomposing waste gradually releases nutrients back into the soil. And this is like a safer option than using ammonia fertilizer, since it's not as densely concentrated as ammonia. However, there are cons, as the compost can take a really long time. It can range from 2 weeks to 2 years, which isn't very time efficient if you need your crops down. And then, but adding components like worms or animal manure can help speed up the process. And then it's not completely risk-free, as compost does produce greenhouse gases, but not at the same rate that ammonia fertilizers do. Another course of action we can look at is biofertilizers. So biofertilizers are a product that contains microorganisms, and then these microorganisms are able to accelerate microbial activities in plants and increase the availability of nutrients for the plants. These microorganisms are also able to fix atmospheric nitrogen and then make the phosphates that are insoluble soluble, and then they're more readily available for the plants to use in the soil. So some cons to this are that they're not as nutrient rich as chemical additives, so a lot more product is needed. They have a shorter shelf life, and then they're also plant specific, so each different crop would need their own form of biofertilizer, which doesn't really make it cost efficient. So like it's not really a lot of bang for your buck with this option. And then they also stink. And then here we have our sources. And we're excited, and thank you.